What if the greatest agricultural success story in history was not born from fertile river valleys, but from stone, slopes, and scarcity? The Incan Empire presents a profound economic paradox. It achieved unprecedented food security in one of the most volatile environments on Earth. This was not magic. It was a feat of systems engineering. Now, let's open the historical ledger and analyze the economic blueprint this crisis left behind. To understand the Incan achievement, we must first analyze the ordinary world they inhabited. This was not a world of gentle plains or predictable rivers like the Nile or the Industry. The Andes, the Tawantinsuyu, or for quarters of the Incan world, represent one of the most severe sets of economic constraints on the planet. The primary antagonist is not a rival state, it is gravity. When we analyze the topography of the Andean heartland, we see a vertical world. Arable land, the flat, fertile soil necessary for traditional agriculture, is statistically non-existent. We're looking at slopes of 30, 40, and even 60 degrees. In this environment, the default state of any agricultural attempt is failure. The soil, loosened by a plow, simply washes away with the first rain. Water, the second variable, is equally problematic. It is either catastrophically abundant in seasonal deluges or completely absent for months. This environment creates an economic system defined by extreme risk and volatility. For the pre-Incan societies inhabiting these slopes, life was a high-stakes gamble. As the archaeological record shows, settlement patterns were small, scattered, and defensive. They existed in a state of perpetual resource stress. A single frost, a localized drought, or a hillside landslide could erase a village's entire food supply for the year. This is a classic subsistence economy, trapped by a low production ceiling. There is no surplus. Without surplus, there is no specialization. Without specialization, there is no capacity to build cities, support armies, or fund the complex bureaucracy of a state. This was the economic problem the Inca inherited as they began their expansion from the Cusco Valley around the 13th century. The inciting incident for their great innovation was not a single event, but the fundamental crisis of imperial ambition. To build an empire, the Inca state, the Sapa Inca, and the centralized priesthood require a massive, reliable agricultural surplus. This surplus was the state's primary capital. It was needed to feed armies on the march, to provision the MITA labor drafts building roads and temples, and to provide social insurance against the very famines that kept their rivals weak. The existing, scattered, and high-risk farming plots were completely inadequate for this task. The Incan state was facing a systemic ceiling. They could not expand horizontally. The fertile valleys were already occupied and insufficient. They could not rely on trade for bulk calories, as the cost of transporting food over the Andes was prohibitively high. Their only option was to solve the problem of verticality. They had to find a way to create new farmland where none existed. This challenge was, at its core, an engineering problem. How do you defeat gravity? How do you control water? And how do you mitigate the extreme climatic risk of the high altitudes? The Inca's predecessors, the Wari, the Tiwanaku, had experimented with terracing. But these were localized solutions. The Inca were the first to identify this practice not just as a farming technique, but as a scalable instrument of state policy. They saw it as the fundamental solution to their core economic crisis. They recognized that to secure the empire, they first had to secure the calorie. The problem was clear. The land, in its natural state, was an economic liability. It could not support their ambition. To build the future they envisioned, they would have to completely re-engineer the economic foundation of their world. They would have to turn the greatest liability, the steep, rocky slopes of the Andes, into their most productive asset. This decision, to confront scarcity not by fleeing it, but by engineering it, marks the beginning of their journey. The Incan response to this systemic crisis was not a minor adaptation. It was a total re-engineering of their environment. The ordeal for the Incan state was a monumental campaign of civil engineering, and their weapon was the Anden or the agricultural terrace. When we look at the ruins of Pisac or Ollantay Tambo, what we are seeing is not just a farm. We are analyzing a sophisticated, multi-layered capital asset designed to solve three distinct economic problems simultaneously: the creation of new land, the management of water, and the mitigation of climate risk. Let's deconstruct the Anden as a piece of technology. An on-screen diagram of a terrace cross-section reveals its complexity. This is not merely a wall holding back dirt. First, the structural foundation. The Incan engineers began by building a stone retaining wall, often over 2 meters high. These walls were not crudely stacked. They were masterpieces of dry stone masonry, precisely fitted to withstand seismic shocks and hydrostatic pressure. The primary economic function of this wall was to defeat gravity. It created a new, perfectly flat surface, arable land, where only a useless slope existed before. This was, in effect, the privatization of the Z-axis. Second, the hydrological engineering. Behind this wall, the Inca did not simply backfill with soil. This would have led to waterlogging and the eventual collapse of the wall. Instead, they engineered a sophisticated drainage system. As illustrated here, the bottom layer consists of coarse gravel and crushed rock. This layer acts as a massive filter, allowing excess water from seasonal deluges to percolate through safely, preventing soil erosion and structural failure. Water was not an enemy to be fought, but a force to be managed, tamed, and channeled. Third, the creation of the asset itself. Above the drainage layer, they added a middle layer of sand or mixed medium, and finally, a top layer of rich, dark topsoil. Here, we uncover a crucial economic insight. This topsoil was often quarried from fertile valley floors kilometers away and transported up the mountains by llama caravan and human labor. We must be clear, the Inca were not farming the land. They were manufacturing it. They were building a biological and geological machine designed for one purpose: the creation of a predictable agricultural surplus. This machine, however, could not function in isolation. The Andes were the individual production units, but they needed to be connected to the broader state infrastructure. The next layer of the system was water conveyance. Incan engineers built thousands of kilometers of precision-graded canals and stone-lined aqueducts. These channels captured glacial meltwater and seasonal rain from high in the Puna grasslands and distributed it through a complex system of gates and tertiary channels to each individual terrace. When we analyze this system, we see a fundamental shift in the economic relationship with resources. Water was no longer a volatile, unpredictable event, a drought or a flood. It became a managed utility, a state-controlled input, allocated by engineers to maximize caloric output across the entire system. This infrastructure decoupled food production from the immediate, chaotic local weather. But the most elegant part of this system is how it solved the problem of climate risk. The Andes are a world of extreme temperatures. A single night of frost, common at high altitudes, can wipe out an entire potato harvest. The Anden was designed as a passive insurance policy against this risk. The stone retaining walls, with their high thermal mass, would absorb intense solar radiation during the day. As this diagram of the thermal cycle shows, the stones would then slowly release this stored heat during the freezing night. This created a localized microclimate, warming the soil and the air immediately around the crops by several crucial degrees. This small thermal buffer was often the difference between a total loss and a full harvest. This was risk management, engineered in stone. So, how was this monumental ordeal financed? The Incan economy did not use currency. Its primary financial instrument was labor. The construction of this agricultural infrastructure was funded by the MITA, a system of compulsory rotational labor. This is the core of the Incan economic rebalancing. The ailis, or local communities, would provide labor to the state for a portion of the year. This labor, a tax, paid in time, and energy, was the investment capital. The state, acting as the project manager and chief engineer, directed this capital into the construction of these Andenes, canals, roads, and storehouses. The payoff for the community was twofold. First, the state granted the ailu usufruct rights to a portion of these new, hyperproductive, low-risk terraces for their own subsistence. Second, the surplus harvested from the state-owned terraces was transported to a vast network of kulkas, or storehouses, built along the Kapaknan road system. These kulkas were the strategic reserve. They were the Incan equivalent of a central bank and a national grain reserve combined. When a region faced a local drought or a crop failure, which the terraces mitigated but could not always eliminate, the state would open the kulkas and distribute food to the affected populace. This was the Incan social contract, written in stone and water. The MITA was the investment. The Andenes were the durable capital good that made the investment productive. And the kulkas were the social insurance that guaranteed the system's stability. When we analyze the whole system, the rebalancing is clear. The Inca had transformed a volatile, subsistence-based economy into a centralized, surplus-based command economy. They had broken the ceiling of their environment. They did not just find food. They engineered the security, predictability, and surplus that became the foundation of their entire empire. They had taken temporary human labor and converted it into a permanent, multi-generational asset that continues to produce food to this day. The return from the Andean heights brings us back to our modern, ordinary world, but we do not return empty-handed. We carry the elixir, the Incan framework. This is the intellectual tool that allows us to see our own challenges in a new light. The ultimate achievement of the Inca was not just the creation of food. It was the mastery of volatility. They took a high-risk, low-yield, and unpredictable environment and, through a massive, one-time capital investment of labor, transformed it into a low-risk, high-yield, and utterly predictable asset. They engineered scarcity and volatility out of their core economic equation. This is the gift of the mentor, the lesson from the ledger. Now, we must apply this analytical framework to our own contemporary economic challenge. The profound instability of our 21st century food system. Our modern agricultural system, the marvel of the last century, was built on a different premise. We did not face scarcity of land. We had vast, fertile plains. Our system was not engineered for resilience. It was engineered for efficiency. We optimized for maximum yield at minimum cost, assuming a stable climate and cheap, abundant inputs, namely fossil fuels and limitless water. Today, those assumptions are breaking. As on-screen data regarding climate volatility, aquifer depletion, and topsoil loss illustrates, the ordinary world we built is now facing its own systemic shock. Our system is revealed as brittle. Its efficiency is its weakness. We have optimized for a good year, but we are increasingly facing bad ones. This is where the Andean framework for resilience provides a new blueprint. It is not about building stone terraces. It is about adopting the economic principles that made those terraces successful. First, the principle of durable capital investment. The Inca converted a temporary input, human labor, into a permanent asset, the Andenes. Our modern system often does the opposite. As this chart on soil degradation shows, we often deplete permanent capital, topsoil, ancient aquifers, for temporary gains, a single season's profit. The Incan framework demands we shift our investment from short-term consumables, like synthetic fertilizers, to long-term capital assets. This means funding massive infrastructure projects in soil regeneration, sustainable water capture, and localized energy grids. It is the modern MITA, a state-level investment in the foundations of production. Second, the principle of integrated systems over silo components. The Andenes was not just a wall. It was a single machine that solved land use, water management, and climate risk simultaneously. Our modern approach is siloed. We have one system for irrigation, another for fertilization, and a separate financial system for crop insurance. The Incan model demonstrates the power of systemic integration. It forces us to ask, how can we design agricultural systems where, for example, water-holding swales and nitrogen-fixing cover crops are not costs, but integrated parts of a system that produces its own fertility and insurance? Third, the principle of resilience as the primary metric. The Incan microclimate, engineered to fight frost, was less efficient in its use of space than a flat field. But it was infinitely more resilient. It was designed to not fail. Our system, built on monocultures, is the epitome of efficiency and the epitome of fragility. The Andean framework forces us to reevaluate our metrics. A resilient system, which may involve crop diversity, agroforestry, or localized colcas, storehouses, may look less efficient on a spreadsheet in a perfect year. But its true value is revealed in its ability to withstand the shocks that are now becoming the norm. The Incas looked at a 45-degree slope and did not see a liability. They saw the raw material for an asset. They did not flee from scarcity. They re-engineered it into a platform for surplus and security. This is the intellectual weapon they have given us. When we analyze our modern resource crises, water scarcity, land degradation, climate volatility, we are no longer just passive observers. We are analysts. The Incan framework provides the lens to see these not as insurmountable problems, but as systems awaiting a new design. The historical ledger reveals an enduring pattern. Economic systems are our tools for managing scarcity. The Inca, facing a world of stone, engineered a system of permanent security. We, in our modern world, now face the challenge of volatility. The Andean blueprint is a timeless framework, proving that true wealth is not the harvest of a single season, but the resilience of the system that guarantees all seasons to come.